This is the first in a series of videos on sequences, and we're just going to go over some definitions and some examples in this video. So the first thing is, what is a sequence? What do we mean when we talk about a sequence? Well, here's some examples. A sequence is just a series of numbers where every single number has a value. For example, that's the number 20 and that's the number 30. And in addition, each individual number has a place in a sequence of terms. So for example, this is the first number, the second number, the third number, the fourth number, and the fifth number. And sequences can either be in simply a list of numbers, and this is the first example here, 10, 15, 20, 25, 30, etc. Or it can be in table form. And as in table form, an example would be something like this, an x and y. Sometimes y is called f of x. It just means the same thing, where this is the number or the place in the sequence, like this represents the first term, the second term, the third term, the fourth term, and the fifth term, and this is the value of the first term. So the way to read this is the first term is 10, and the second term is 20, and the third term is 40, and the fourth term is 80, and the fifth term is 160. In addition to using the variables x and y, sometimes they use x and f of x. That's fine. But other times they use the number n and a sub n, where n is the variable that represents which term. So for example, right here we have n is equal to 3, which means it's the third term in the sequence. And a sub n would be the value of the third term. So 40 is the value of the third term. This is just some notation, really, and you have to get used to the notation. It's not too difficult with practice. The first thing I want to talk about in this video is the three common sequences that we'll be going to go over and the definitions of each one. So the three types of sequences we're going to deal with are arithmetic, geometric, and quadratic. Just to complicate things a little bit, arithmetic is sometimes called linear. These terms simply mean exactly the same thing. Geometric is sometimes called exponential. What are the rules for each one of these? Well, the rule for arithmetic is that the first differences are constant. So the key to an arithmetic function is you add or subtract some number. And the formal way we say that is we say that we have constant first differences. And we'll go over an example in just a second. For geometric or exponential, those are always simply when you take each term and you either multiply or divide. Sometimes that's obvious, sometimes you'll need a calculator to solve through it. The formal way we say multiply or divide is we say that there is a constant ratio. And quadratic is the third type. You can think about arithmetic and geometric as the two basic type of sequences, and quadratic is the first new type of sequence, or complicated type of sequence that we learn. Quadratic isn't as obvious as adding, subtracting, multiplying, dividing, but it does have a straightforward rule or definition. And the definition is that you have constant second differences. And in this video, what we're going to do is we're going to talk about an example of each one of these. So arithmetic, linear, add and subtract, constant first differences. Geometric or exponential, multiply and divide, you have a constant ratio, and quadratic means you have constant second differences. So let's do an example. So as a first example, let's say we have 10, 16, 22, 28, 34, etc. Well, you might see it automatically, or what you might do is you might plug in some numbers here. If you take 16 minus 10, right? If you go 16 minus 10, you get a 6. In other words, as you go from 10 to 16, you add 6. When you go 16 to 22, if you subtract that, 22 minus 16, you also get a positive 6. 22 to 28 is a positive 6. 28 to 34 is a positive 6. Whenever you're adding a certain constant number or subtracting, then we call that difference. We often use the letter D to call it the constant difference or constant first difference. In this case, it's a positive 6. Now you want to be careful here to get your positive and negative. It's a positive 6 because each term we go up 6. That's the definition of an arithmetic function, so that means that is an arithmetic function. That's just a simple example of an arithmetic sequence. Geometric is often just as easy, sometimes not, but often just as easy. Now, let's say you have one where it's 20, 40, 80, 160, 320. The formal way that you find out the constant ratios is you take one term and divide it by the previous term. So you have 40 divided by 20, 80 divided by 40, 160 divided by 80, and 320 divided by 160. If you plug those in a calculator, you get 2, 2, 2, and 2. So R is called the constant ratio. In this case, R is equal to 2. So we say this is geometric. Geometric or exponential, whatever term you'd like to use. Sometimes geometric is a little more complicated. So let's look at another example. Let's look at one that goes 100, 90, 81, 72.9, etc. Now, from just looking at it, this is not obviously arithmetic or geometric. We can look at it and could say, well, this is minus 10, and that's minus 9, and that's minus about, not quite 8. So it's clearly not arithmetic. So to find out if it's geometric, it's not obvious. Now, sometimes it is, right? If you think about the previous example, we could just look at this and see, well, this is multiplied by 2 each time. On this one, it's not so clear, so let's use the same method. So we take one term and divide it by the previous term, so that's 90 divided by 100. One term and divide it by the previous term, so that's 81 divided by 90. One term divided by the previous term, so that's 72.9 divided by 81. I'm just going to use a calculator real quick. 90 divided by 100 is going to be 0.9. 81 divided by 90, let's do that. 81 divided by 90, that's a 0.9. 72.9 divided by 81 is also 0.9. So if you see here, every time that you take one term and divide it by the previous term, you get the same number. That means you get a common ratio, and R, our variable we use to define the common ratio, that's going to be 0.9, and this is going to be a geometric function or sequence. You can also call it exponential if you want to. So you have to be careful of that. Almost all the time, let's go back to our arithmetic example. On our arithmetic example, almost always you can just look at it and see, oh, this is arithmetic. Geometric, most of the time you can just look at it and say, yeah, that's geometric. But there are examples, and this is one, where it's a geometric function and it's not so obvious. The third example we have is a quadratic. Quadratics are going to be a little bit more difficult to see. So let's do an example of a quadratic. So let's do 2. And then let's do 5. And then let's do 10. And then let's do 17. And let's do 26. So we can look at that and see, well, that's clearly not arithmetic, right? Because here you add 3 and then 5 and then 7. So it's not clearly not arithmetic. You can just look at it and see that. It doesn't look like it's geometric either, and we could plug the numbers in and see that it's not geometric. So if it's not arithmetic or geometric, then it might be quadratic or it might not be. The way you do quadratic is first you do first differences. So you go 5 minus 2. Be careful with your pluses and minuses. 10 minus 5 is 5, so that's plus 5. 10 to 17 is plus 7. 17 to 26 is plus 11. Plus 9. Sorry, my bad. 26. Let me use a calculator and double check that. That's 26 minus 17. Yeah, that's going to be 9. So those are called first differences, and those are not the same. So if the first differences aren't the same, what you can do is you can find the differences again, and that's called second differences. So 5 minus 3 is a plus 2. 7 minus 5 is a plus 2. 9 minus 7 is a plus 2. So if you notice here, the second differences, these are called the second differences. All the second differences are going to be equal. And if the second differences are equal, that means it's going to be a quadratic, right? So let's go to the rules again. If it's arithmetic linear, you have constant first differences. Geometric exponential, you have constant ratios, multiply or divide. Quadratic is constant second differences. So this is an example of a quadratic. So that's the basic rules, and we'll go on and do some more examples in the following videos.